So welcome to today's lesson on naming and writing formulae for type 3 compounds, which involve polyatomic ions. Remember, with polyatomic ions, you're expecting to see more than 2 capital letters found in the compound, and this list can be found on the back of the periodic table that you colored. So let's get started. So naming multivalent ionic compounds, for example, MgSO4. So notice that the SO, you have 2 capitals in addition to the metal, which is magnesium. So look up the polyatomic ion on the chart. So again, back of the periodic table or page 2. SO4 has a 2- charge and it is called sulfate. Do not mix it up with sulfite. Write the name of the metal like you would for the simple ionic. So magnesium has a 2+ charge. Do not capitalize the name of the metal. So magnesium, and then for the second part of the name, just write the polyatomic ion as written on the chart. So we do not need to change the ending. It's just magnesium sulfate. Note, there is one polyatomic ion that is positively charged, replacing the metal. So this is ammonium, Nh4+. Note that this is ammonium, not ammonia. So careful with that. So NH4 1+ ammonium. So in this case, we use ammonium in the first part of the compound name. So this is the only one where this will happen. So for example, NH4Cl is ammonium chloride. If the metal ion is multivalent, you must use a Roman numeral when you write the name of the compound. So for example, if you were to follow yesterday's protocol, we would find out that iron, Fe, has a 3+ charge. You can also see it in this position. You just want to double check that it's not reduced. So it's iron 3 carbonate. So now I would like you to pause here and try these 3 examples following what we just learned. Okay, so I'm just going to walk you through these examples. Sodium only has 1 charge, and when you look at SO4 on your common polyatomic ions, you see that it also only has 1 charge option. So Na+ is sodium, and SO4 2- is sulfate. Really be careful with these endings. Sulfate and sulfite are polyatomic. Sulfide is just S in the position of the non-metal. So this one will be sodium. So final name is sodium sulfate, all lowercase. Second example is made up of manganese, which is polyatomic. And if you look on the common polyatomic ions, this is permanganate or permanganate. Manganese has multiple charge options. So in this case, we need to actually figure out the charge on it. So Mn, MnO4, which only has 1 charge option. So this is a -1, and this one is a we're not sure. What we do know is that we have 2 MnO4s, which will give us an overall charge of 2-. So that means for manganese, it also must have a 2+ charge to balance this out, but we only have 1 of those. So with that, we can determine that this is. Okay, last example. In this case, ammonium only has 1 charge, and it's a -1, and sulfur also only has 1 charge, which is a 2-. So ammonium we can name directly, and then ammonium sulfide is your answer for this one. So take a moment to just check these over and make sure they match with yours. And then we're going to go into writing formulas. So our example provided is iron 3 sulfite. Again, watch the ending. Write down the cations and anions with their charges. So iron 3 from the Roman numeral tells us it's iron 3 plus as a charge. Sulfite is SO3, so not SO4, SO3 2 minus. So these are our two charges. We want to balance out the charges. So we need the two irons together give us 6 plus, and then the 3 sulfites give us a total of 6 minus. So that is balanced, meaning we have 2, so Fe2, and then SO3, 3, telling us how many of each we have. So write the formula. If there is more than one of the polyatomic ion, put it in brackets. So it's important that you separate these two 3s, as this outer 3 means that it applies to the number of atoms of oxygen as well as sulfur. So that's why it must be separated by brackets. So be careful with that. Okay, so I'm going to get you to pause here, and then I will get you to write formulas for the following named compounds. Okay, so magnesium cyanide is magnesium has a 2 plus charge, only has 1, and cyanide from the polyatomic list has a Cn, so minus. This means this is a 1 minus charge, and this is a 2 plus charge. To balance out our 2 plus magnesium, we are going to need 2 1 minuses, giving us a 2 minus charge to balance out the 2 plus. So this just means the overall charge is 0. So this then becomes magnesium. We only have 1, but we have 2 cyanide ions. So you need that little 2 on the outside separated by brackets, because the 2 applies to not just the nitrogen, but also the carbon as well. Okay, tin for silicate. Tin, we are told from the Roman numerals, has a 4 plus charge. Silicate is SiO3 2 minus. So this has a 4 plus charge. This has a 2 minus charge. So SN 4 plus, and to balance that out, we are going to need to silicate. Two minus plus 2 minus is equal to an overall 4 minus charge to balance out the 4 plus charge. Tin, we only have 1, but the brackets, SiO3, and we have 2 of them. So you don't need the brackets unless you have more than 1 when we're balancing out the charges. So our last example is ammonium sulfate, Nh4 plus from the back of the periodic table. And then sulfate has an SO4 2 minus charge. So in this case, we actually have 2 polyatomics. So this is a 1 plus charge, and this is a 2 minus charge. So Nh4 plus SO4 2 minus. Okay, so to balance out the 2 minus charge from the SO4, the sulfate, we're going to need 1 more ammonium ion, giving us an overall 2 plus charge to balance out the 2 minus charge. So because we have 2 NH4s, we need to surround it by brackets, put the little 2 outside, saying we have 2 of that whole group, and then we only have 1 SO4. Okay, that is the end of today's lesson. So please make sure you're following the schedule and follow the instructions provided on what to do for your assignment now.